Earthquakes are one of the most dangerous geologic hazards. What is an earthquake? It's simply a vibration of Earth due to a rapid release of energy. Most of the time, this rapid release of energy happens along faults, but that's not the only place. One of the examples you're going to see here, this is an earthquake in Ecuador. It occurred on April 16th, 2016. It's one of the largest ones recorded there. It was a magnitude 7.8, which is really big. Unfortunately, this one was actually pretty destructive. It killed 668 people. There are 8 people that are still missing after all this time, and it seriously injured over 6,000 others. That's along with destroying houses and buildings and businesses throughout the region as well. And it's felt over a larger area, not just in Ecuador. And one of the big things that characterize an earthquake is this shaking. And you can see there's definitely a lot of shaking going on here. You can see there's a little bit, actually, when it very first starts, you can see the monitors moving. Then everything starts shaking a whole lot more. Like I said, these are normally along faults. That's not the only place. There are other ways to release a whole lot of energy really quickly. For instance, the top left is a picture of an explosion at a mine. Mines tend to use a lot of explosives to break up their ore into smaller, usable pieces. Right beside that is a landslide. This is along the coast of, I believe, Wales, somewhere in the UK at least. Sometimes these landslides are really big and they can actually shake the ground, and they get picked up on seismometers, which is pretty cool. Bottom right is actually a nuclear test. Now, back in the day, we used to test these nuclear bombs just out in the middle of the ocean. But we haven't done that in a long time, and there's actually pretty strict rules as to who gets nuclear bombs and who doesn't. But unfortunately, a lot of people who probably don't need to have them do have them. And so if somewhere like North Korea is going to test their bombs, they do it underground. And when they do those underground, it sets off seismometers all over the world, so we know exactly when they happen. One of my favorite there is on the bottom left, though. This is a fireball in Russia in 2013. You may remember this. This is a tiny piece of probably a piece of an asteroid that entered the Earth's atmosphere at over 40,000 miles an hour. What that does is it creates a shock wave and a whole lot of heat. And when that shock wave hits the ground, it shakes the ground. In this case, it actually registered on seismometers as at the energy of about a 2.7 magnitude earthquake. Unfortunately, this one actually hurt a lot of people too, because when that shock wave explodes, not just the impactor itself, but when the shock wave hits the Earth, it actually shattered windows all over the region, and quite a few people were injured by the flying glass. So, like I said, earthquakes usually occur along faults, but where do we find those faults? Plate boundaries. This is a map from USGS of a week's worth of earthquakes. This is including all sizes for the US and the big ones from worldwide. So you can see the bigger the circle, the bigger the earthquake. So it's been a fairly quiet week, which is good. But if you look, the places in the US that have earthquakes include Hawaii, which is a hotspot, Alaska, which is a subduction zone, California, which is a transform plate boundary, the Pacific Northwest, like the coast of Washington and Oregon, that's a subduction zone. But interestingly enough, there's another couple of regions like Oklahoma or Missouri that actually have a whole lot of earthquakes as well. And we'll probably talk about those in the classroom to see when those happen. But you can see in this map, the red lines represent plate boundaries, and that's where by far most of these are happening. So we're looking at just earthquake risk. So just the probability of an earthquake happening is pretty good for some parts of the US, but where are you really at risk? Interestingly enough, of course, California has a high risk, but if we look, New Madrid, Missouri has a very high risk of earthquakes. And that's because over the winter of 1811 and 1812, they had a series of earthquakes. There were 4 really large ones, some as much as maybe 7.9 in magnitude, and thousands upon thousands of smaller ones. And this is an area that is still really active too. Lots of little earthquakes, not a lot of big ones. But as you can see in the map, this is affecting a large number of states like Missouri, Illinois, Kentucky, Tennessee, and Arkansas, as well as anything kind of bounding that like Mississippi, Indiana. So there are lots of places that are really vulnerable right now. Some of the interesting results of this is the Mississippi River actually ran backwards for a small amount of time. And that's because when the earthquakes happened, there were fault scarps that developed, and the water was bouncing off the fault scarp and was forced the other direction, or in some cases, it actually formed waterfalls along the Mississippi River. The good news is that there were very few deaths at the time, but in 1811, there weren't just a whole lot of people here, particularly white folks, which is sadly enough what gets recorded the best. There were probably a number of Native Americans that lived in the area that may have been killed. We just don't have records of them. But now this is a lot different. You have a lot of cities right around there. St. Louis, Missouri. You have Tennessee. You have Memphis, Tennessee. That's really close. So the effects of this happen again would be a lot worse at this point. The good news is it sort of looks like these earthquakes happen on like 300-year cycles. The bad news is that doesn't always work out. So this is an area that needs to be at a really high level of awareness, and they need to really update and retrofit their buildings and make new building codes to get them ready for it, and because they really aren't. If we want to look at places that do have really big earthquakes and are sort of ready for it, we got to look to Alaska. It's a subduction zone. Subduction zones are where the biggest earthquakes are going to happen. These massive magnitude 8, magnitude 9 earthquakes, these are often known as mega thrust earthquakes because it's happening with thrusting. Remember thrust faults along subduction zones. So that's where you can build up a whole lot of energy. So the largest one in U.S. history is the Good Friday earthquake from 1964. Now this was actually on Good Friday. This doesn't mean the day was particularly good. It was actually pretty bad for them. A magnitude 9.2 earthquake is the largest in U.S. history, the second largest in world history. You had effects from the earthquake. There was a tsunami. There was a massive landslide and liquefaction, which actually caused the landslide. They covered a really large region. There were 139 deaths. Only 16 of them were directly from the earthquake itself. The rest of them were from the tsunami that was triggered, including 12 people in Crescent City, California, and 4 children that were killed in Oregon. Apparently, there was a Boy Scout group that was camping along the coast. So why do earthquakes occur? We've talked before about faults. So a fault is a break in the rock on which movement occurs, and that movement's really important. So where the earthquake starts is called the focus. So the focus is the location on a fault underground where an earthquake originates. And so as soon as that fault moves, it releases its energy, and the energy starts moving away from the focus in waves all around, completely radially, like spherically. That's where the focus is. But you never really hear about that. What you do hear is the epicenter, and the epicenter is the place on the surface that's directly above the focus. In general, but not always, the epicenter has the highest damage because it is affected by the highest amount of energy. That focus is also sometimes known as the hypocenter, and that sort of matches epicenter pretty well. Either one of those terms is fine, though, focus or hypocenter. Now what happens through this theory of an elastic rebound. So we've talked about rock deformation. That's what faults and folds are all about. When a rock deforms plastically, it bends and it stays bent, and that's why we get anticlines and synclines. When a rock deforms brittly, it breaks. But then there's the elastic deformation. And in elastic deformation, your rocks are able to bend under stress. But when that stress is released, it returns to its original position. And so what happens is you have an undeformed stick here in the picture, right? That's what's happening on the fault. No deformation so far. And then you add stress, all right? And stress results in strain. Things start moving. So this over here is a lot like the San Andreas Fault system. So you have the Pacific Plate moving north and the North American Plate moving south. And we tend to draw faults as this nice straight line, but they're not a straight line and it's not a smooth surface. It's rocks grinding against one another. So think of like sandpaper, two sheets of sandpaper face to face that you're pushing against. Well, it's not always easy to push. What happens is, as the earth is pushing, the stuff behind it is pushing and it's bending the rocks, but those two chunks of sandpaper are locked together. Eventually, though, the stress is going to be higher than the strength of the rock or whatever friction is holding it together. And those rocks move and break. When it breaks, those rocks go back to its unbent position. So now, instead of one bent stick, you have two straight sticks because they have bounced right back to their original position. It's that bouncing back to the original position that causes the earthquake. That's what releases that energy. Now, some terms we should probably make sure we mention are things like the main shock. So for instance, in 2011, there was an earthquake in Japan. You probably remember this. It was a magnitude 9.0, 8.8. I forget what the exact number was by the time they got done. So what we have here is a graph of earthquakes over time. The numbers are they're just sequentially graphed. Over here on the left, these are the magnitudes. So this really big one up here that's labeled 9.0, this is the main quake or the main shock. So that is the earthquake. And it's defined as the earthquake or the main one because it's the biggest. But if you notice, there are earthquakes that happen right before that. These are called foreshocks. Those are little earthquakes that happen before a big earthquake. And if you've ever tried to break a stick before, like the little image in the previous slide, as it's starting to bend and before it breaks, you can hear it go kind of snap, crackle, and pop, right? Its little bits are starting to let loose. That's what these foreshocks are. Now, foreshocks are usually, they're always smaller than the main quake, but sometimes they're really big. For instance, in this case, there was, in a week or two before this earthquake, there was a magnitude 7.2 earthquake. And that's a good-sized earthquake. And everybody was like, whoa, that's a big earthquake. Until the really big one happened. And then it was pretty obvious that, yeah, that was a big earthquake, but that was a really big foreshock because it happened before. Now, remember, these faults aren't smooth. It's like sandpaper. So once things start to move, there's still some adjusting to try to get back in that original position. So everything's still creeping and moving around. And so that is what causes aftershocks. So aftershocks are small earthquakes that occur after a large earthquake. And in this case, there's some of these that are really big too. And there's a magnitude 7.2 plus a lot that are greater than a magnitude 6. And usually a magnitude 6 is where our cutoff. Anything bigger than that is a pretty moderate to good size earthquake. So you can see just how many of these there were. Now, you can't really see time this way, but right after the earthquake is when you have the most aftershocks. And then the day after that, you're going to have about half as many. And the day after that, you'll have another half as many. So it dies down pretty quickly. But in this case, they had aftershocks for years. Or at least months in this case. There are some earthquakes that are in fairly inactive regions that have them for lots and lots of years. Like the New Madrid at Missouri area. Even now there's earthquakes there, and those may just be aftershocks from the big ones from 1811 still.